In this short video, let us understand the concept of the supernode. So the supernode concept is typically used during the circuit analysis, and specifically when we are finding the voltage and current in the circuit using the nodal analysis. So typically, as we know, in the nodal analysis, we have one reference node and we have some other non-reference nodes. So for example, in this case if you see, then this is our reference node. But apart from that, we also have the non-reference nodes. So here if you see, then we have the three reference nodes. Let's say the voltage at these three nodes are V1, V2 and the V3. So typically in the nodal analysis, when we have the resistor between the two nodes, then using the Ohm's law, we can easily find the current that is flowing between the two nodes. But whenever we have a voltage source between the two nodes, then it becomes difficult to find the current that is flowing between the two nodes. So we can say that whenever we have a voltage source, either an independent or the dependent source between the two nodes, then those two nodes can be combined together and they can be considered as the supernode. So in that condition, while applying the KCL equations, instead of considering the two nodes separately, both nodes are considered as the single node. So let us see, using that concept, how we can find the voltage at each node. So in this case if you see, then between the node V1 and the reference node, we have this 5 volt voltage source. So we can say that the V1 is equal to 5 volt. And now let us apply the KCL equation at this super node. So if we apply the KCL equation, then we can write this V2 minus V1 divided by 4 ohm, that is this current, plus V2 minus 0 divided by 8 ohm, that is this current. Likewise, here since the both nodes are considered together, so in the same expression, we will also have the currents due to the V3 node. That means here, the third current will be equal to this V3 minus 0 divided by 4 ohm. And likewise, the fourth current will be equal to this V3 minus V1 divided by 6 ohm. And the summation of all these outgoing currents will be equal to 0. So in this expression, let us put the value of V1 as 5 volt and let us further simplify it. And here, between these two nodes, we know that the voltage is equal to 3 volt. So we can say that here this V2 minus V3 is equal to 3 volt. So now, if we solve these two expressions, then the value of the V3 will come out as 1.21 volt, while the value of the V2 will come out as 4.21 volt. So in this way, during the nodal analysis, when the voltage source is connected between the two nodes, then using the concept of the supernode, we can easily perform the nodal analysis.